Assalamu alaikum. Hopefully you are fine and you're doing well in your studies. So today my topic of discussion is the remaining part of the question number 2a part 2. Give the structures and the names of the two structural isomers of C7H16 which contain a chiral center. What do you mean by the word chiral center? Actually, in the previous part we have studied the chiral carbon or the chiral center is that carbon which to which four different groups are attached. They may be are, for example, this is the carbon and the different four different groups may be attached. It may be ethyl, it may be methyl, it may be halogen, it may be OH, it may be simple H. So these are the actually this is the chiral or the central carbon. So the question is identify the structure which contain a chiral center, and the formula should be C7H16. So here we go. This is the actually formula 3-methyl hexane. So this is the one structure. I can show the formula. So this is the 3-methyl hexane. As you can see here, the carbon, it is attached to four different groups. One is the hydrogen, the other one is the ethyl, the third one is methyl, and the fourth one is propyl. So this is the actually structure that is that contains chiral carbon. So two are demanded. So one is 3-methyl hexane and the other one is 2,3-dimethyl pentane. Here we can draw the structure. So here is the actually 2,3-dimethyl pentane. So here we can see this carbon is not, but this carbon contains a propyl, methyl, ethyl, and one hydrogen. So these are two structures which contain actually the chiral center. Write an equation for complete combustion of heptane. So heptane is C7H16, and how many mole of oxygen are added to form the carbon dioxide plus water. So here we can see 7 CH2C, and for the complete combustion 7, or here we can see 16, so 8, and according to this oxygen must be 8 plus 14, 22 or 11, so 11 O2, and this is the equation for the complete combustion. Write an equation for the incomplete combustion leading to the production of the solid pollutant. So solid pollutant is actually carbon black, not the actually carbon monoxide or carbon dioxide. So for the incomplete combustion we can see here C7H16 plus O2 and 7C plus 8H2O. So here we can see 4O2. This is the incomplete combustion. So the next is incomplete combustion can also lead to emission of unburnt hydrocarbons. So many unburnt hydrocarbons are emitted or removed or released. State one environmental consequence. Environmental consequence actually it causes the global warming. After that it cause actually smoke, and it is called global dimming. So these are the effects actually. After that, part C, the reaction of heptane with the chlorine in the presence of UV light produces a wide variety of products. Formation of monoheptanes actually, monochloroheptane can represented by the following. Name the actually following. This is the equation. Name the mechanism of the reaction between heptane. So name of the mechanism actually free radical substitution. Describe the mechanism using the suitable equation including the name of the each stage in this reaction. So here there are three steps actually: initiation, propagation and termination. So here is the initiation, that is the Cl2 Cl. So the point to ponder is, for the determination of free radical, only product sites contain free radical, and for the propagation, reactants and products both must contain free radicals. So here we can see C7H16 plus Cl free radical, and it will give us C7H15 free radical plus HCl, and after that C7H15 free radical plus Cl. So it will form the C7H15Cl plus Cl free radical. So this is the propagation actually, and after that there is termination step, and the termination step is actually we identify the termination step as the step in which only the reactant sites contain free radical. For example, here we can see C7H15 free radical plus Cl free radical. It will go as C7H15Cl plus, so only you can see this is the termination step in which only the reactant sites contains free radical. So the next question is question number 5. Crude oil is a mixture of hydrocarbons and provides many useful chemicals when processed. Two of the stages involved in the processing of the crude oil are fractional distillation and cracking. The diagram is simplified representation of fractional distillation column, fraction A, B, C, D, E, and crude oil and the fraction F. Question is, what has to be done with the crude oil before it enters the column? Actually, we can say boil. Actually, we boil the materials, or we vaporize it to form or to enter into the fractional distillation tower. So what trend in the structure is there for A to F? We can see here the structure A is first of all removed, very quickly removed. So here we can see from A to F there is decreasing volatility. Volatility is being decreased, or we can see boiling points are increased, or we can see carbon chain length is being increased from A to F, or we can see increasing the color, or we can see decreasing the flammability or the mobility. So here is the next part, number 3. State the trends in two properties of fraction A to F. Two properties of fraction. State the trends in two properties. Actually, here we can see there are a lot of properties above same as the boiling points are increasing, and we can see polarizability is increasing, density is increasing. So all these are the answers actually. So the part B, the naphtha fraction from the fractional distillation of crude oil is used as starting material for cracking. Write an equation for the cracking to form the products ethene and the one other in the 2:1. So here we can see C12 and H26. So here we can see 2:1. So C2 should be 2. So 4 carbon and C8. So there must be octane. So it is very easy, and write the equation. It is too quite easy. Thank you.